Welcome to tutorial 4.2 part 2 on precipitation reactions. In this tutorial we're going to write molecular equations for precipitation reactions. We've already seen what these look like in class. And then part 3 is going to be on writing ionic equations for the same reactions. And then part 4 of 4.2 will be on writing net ionic equations. So first, just a quick review of what precipitation reactions are. So first of all, there's a form that basic chemical reactions take. Both precipitation and acid-base neutralization reactions, that's going to come in a later section, follow the same basic form. AX plus BY, and let's not say exactly what those compounds are right now, become AY and BX. In the case of precipitation, the AX and the BY are strong electrolytes, so that's what we're looking at right now. So these two here, the AX would be something like sodium chloride, or calcium nitrate. These are ionic compounds that are soluble in water. That's true for AX and BY. And then if you look at this kind of carefully, you can see it's just a partner switch. The A potentially goes with the Y. We're not sure if it does. And then the B potentially goes with the X. And one of these, either the AY or the BX, has to be insoluble for there to be a chemical reaction. Both of them might be insoluble, but it's more likely that one is insoluble. If there is, there's a chemical reaction. If not, we say there's no reaction that takes place. Here's an example. For example, if you put silver nitrate, a solution of silver nitrate, that's a strong electrolyte that's soluble in water, with potassium chloride, here's what happens. Potentially the silver will find the chloride ions and form silver chloride. And if you look at the solubility chart, you say that in fact takes place. Chlorides are mostly soluble, but not with silver. That's an exception. On the other hand, potassium nitrates might find each other, and if they do bump into each other, nothing's going to happen because all nitrates are soluble, and certainly with alkali metals, they're going to be soluble. So this remains aqueous. And you'll notice that this way of writing things is somewhat misleading, because you're going to say, look, these silver and these nitrates are not really together. They're floating around independently. And that's true, and we'll address that in part 3 and part 4. When we talk about ionic and net ionic equations. But for now, let's just do the bookkeeping in this form. All right, so let's look at a couple of examples. We're going to look at a reaction between lead nitrate and potassium iodide, and we're going to go through it step by step. So here's the first thing. Is lead nitrate soluble? We say, well, let's see. I see nitrates are at the top here. Yeah, they're all soluble. So yes, lead nitrate is soluble. It could act as a reactant in a precipitation reaction. How about potassium iodide? I find iodide again on the top half of the chart. It's soluble. Potassium certainly is not an exception with the iodide. So yeah, these two could act as reactants in a precipitation reaction because both of these are soluble and they're strong electrolytes. What would happen if we mix those? If we mix them, what are the two new partnerships that might form? So you'd say, well, let me see. The lead, that's positive, might find these iodides and turn into something insoluble, or it could be that the potassium might find the nitrates and form something that's insoluble. You say, yeah, either one of those is possible. Well, which of the two is it, though, if either one is going to be insoluble? Is it the lead iodide? Let's see. Iodide is here. It shows it to be mostly soluble. However, lead is an exception. So we say, oh yeah, I think we're going to find something. Lead iodide will precipitate, and therefore it's a precipitation reaction. How about the potassium nitrate? Now the nitrate won't do anything. We're going to call that a spectator ion, the potassium and the nitrate, because they don't join up to form any kind of precipitate. So it looks like this will form a reaction. So let's write the equation down. Let's have some pictures to kind of see what this would look like if we actually did it. So first of all, we have two beakers, two separate beakers here. One of them we dissolve some potassium iodide in. That's this one here. And we said, yes, potassium iodide will be soluble. So the ions will be separate and they'll be floating around independently. This diagram doesn't show the water molecule. So this here would be surrounded by the positive end of a water molecule. And these potassiums would be surrounded by the negative end, that is the oxygen end of some water molecules. And they're all floating around inside here. The same is true for the lead nitrate. We said, yes, nitrates are soluble, so we can dissolve it in a beaker here. And once again, the diagram does not show the water molecules surrounding either the lead or the nitrate. Okay, now we're about to mix the two together, and as soon as the two solutions touch, you see this yellow solid appear. And we already know what that is. That is the lead iodide that's appearing. It forms this kind of cool looking thing in the middle. It'll actually kind of fill up the whole beaker shortly because it's going to everything's going to move around. And the solid is going to be kind of mixed in throughout this liquid environment. And here, if you look carefully, these yellow-purple dots, this is the precipitate that's forming. That is, that's the lead, that's the yellow, joining with the iodide. There's the lead, there's an iodide, there's a lead, and there's the iodide. And if you notice, there's a 2-to-1 ratio. For every lead, there's 2 iodides. There's for one lead, 2 iodides. For one lead, 2 iodides. For one lead, 2 iodides. And these over here, these leads haven't had a chance to find iodides yet. And this one over here, this is some iodide that hasn't had a chance to find any lead yet. Eventually they'll find each other and they'll form either part of this crystal as one big crystal or separate little crystals. In here, there's a lot of separate little crystals inside here. So that's the precipitate. And over time, this thing will kind of form a large kind of precipitate of lead iodide. It'll settle all in the bottom. There's actually multiple crystals that'll be inside here. These other products, this over here is the potassium nitrate, they're still floating around independently. And again, you might complain and say, well, gee, why do we show it KNO3 as if they were some kind of compound? And again, we're going to address that in part 3 and part 4 of this section 4.2. All right, so here's the balanced chemical equation. Same pictures from before. I just copied them over here and look at the equation. This is what we're trying to learn to write in this tutorial. If lead iodide if lead nitrate and potassium iodide were placed into the same beaker, what would happen? We write the 2 possible products, potassium nitrate and lead iodide. We find that one of them is insoluble, the lead iodide. We put the letter S next to it for saying, yeah, that's going to form a solid. The other, if it is solid as well, we'd put an S there, but in this case it's aqueous, so we put aqueous, and then we balance the equation itself. And this is the kind of thing that we're trying to write in this tutorial. So let's look at 2 examples. Write the reaction for the mixing of the solutions of magnesium nitrate and sodium hydroxide. You say, well, how would I do that? Well, if I mix them, what are the 2 new things that might form? Magnesium might form with hydroxide to form a precipitate, and sodium might form with nitrate. And I'm going on the assumption that the original 2 compounds are soluble. So let's go ahead and check that out first. Is magnesium nitrate soluble? Yeah, all nitrates are. How about sodium hydroxide? Well, a lot of hydroxides are not. It's down here. But with the alkali metal, it certainly is. All right, do we get a reaction? Well, let's see. Magnesium hydroxide. I look down here. I see hydroxide. I say, oh, that's insoluble. That's going to precipitate. Unless magnesium's in the list, I don't see it in the list. So yes, I found a precipitate. It's magnesium hydroxide. How about the sodium nitrate? Nah, this is the alkali metal with nitrates. In either case, we're not going to get anything. So the sodium and the nitrate will be the spectator ions. So let's look at our answer. Here's the magnesium nitrate, the original solution with the sodium hydroxide. We put the magnesium with the hydroxide. Here it is over here. And the sodium with the nitrate. Here it is over here. AQ for the spectator ions, S for the solid. And now a few details. I say, well, all right, how did you know to put a 2 over here next to the hydroxide? There was, 1 Na with 1 hydroxide here. Well, why there 2? Again, we're just using the charges to write the right compounds, the formula for those. And all of the charges are given here in the list, so let's make sure we see them. The hydroxide is -1, and we can see that here. It says it right there. There's a little minus sign next to it. And the magnesium is +2. It doesn't show you, there's no periodic table here for you to decipher that directly, but you can tell indirectly because there are 2 nitrates with this magnesium. They're -1 apiece, these nitrates, so you know that magnesium has to be a +2. So you'd put 2 hydroxides with the magnesium, the way there were 2 nitrates with the magnesium over here. And on the other side, you'd follow the same logic. The nitrate's -1. You can see it right here, and therefore the sodium is +1. You can tell from this side, so you know it's Na with NO3. And then when you're finished, you have to balance the equation itself. You say, well, okay, I had 2 nitrates to begin with. Before that 2 was there, I would just have a single nitrate, so I have to add a 2 in the front, and of course 2 in front of the sodium hydroxide as well to get the 2 hydroxides. Now, this is not the greatest way to talk about balancing, too much talk and not enough visuals, but we've done this enough, so I hope that that part's okay for you. Now let's do one more example, and then we're going to try it on the website. We can see it more step by step. Barium chloride and potassium sulfate. First of all, are the two reactants soluble? Barium with chloride, yeah, I think most chlorides are soluble. Yep, barium's not an exception. Potassium sulfate, yeah, I got an alkali metal, so I know it is. So what is the precipitate, if any, that forms? Well, certainly not, it's not going to be potassium chloride. Potassium's the alkali metal, but barium with sulfate, that does precipitate. Sulfate generally does not precipitate. It's up here in the top half, but notice barium is an exception, and therefore it will form the precipitate. So here's the answer. Barium, put it with sulfate. That's our precipitate. And then the potassium with chloride, make sure you keep the charges correct, 1 plus with 1 minus, and then balance the equation. Okay, so that's it, but I think we need to go to the website and try just so you just kind of get the formatting of things on the website so that part doesn't confuse you. So we're going to look at the website here and go through one. This is just a place for you to practice. So let's give this one a shot. Here's the question. What's the write the balanced chemical equation if one takes place? NR is what you write if there's no reaction between these two compounds. So let's not waste time in case there is no reaction. Magnesium with sulfide, will that form a precipitate? And you think, oh yeah, I think I found one. Sulfides are insoluble. Magnesium's not an exception. So yes, there will be a reaction. So I'm going to go ahead and copy this and paste it in that first box. And then I'm going to go ahead and paste it in the second box just for efficiency's sake, so it goes pretty fast. Now what I have to do is switch the partners over here. In the place of the nitrate, I've got to put the sulfide. So I'm just going to get rid of that and make the sulfide. And in the place of the sulfide, I'm going to put the nitrate. And I intentionally just did one of each, so I could use the charges to get these formulas and not looking at look at what the reactant combinations were to mess me up with the charges. Now let's get the charges right. Magnesium is +2, so the sulfide goes with the -2. That's a perfect match. That's our solid. We need a solid, or we're not going to don't have a reaction. And then the potassium is +1 to go with the -1 nitrate. Looks pretty good. So I have everything done except I haven't balanced the equation yet. And now see I have 2 potassiums over there on the left, so I'm going to have to make 2 of these potassium nitrates to use up those 2 potassiums. That also uses up the 2 nitrates, and I think I'm in pretty good shape here. I think I'm going to check this to see if it's right. It says, yep, this is correct, and it nicely reformats it for you, showing you all the subscript and the superscript that go with it. Okay, I think that's good enough. I do them always the same way. Check first so you don't waste time. If there is a precipitate, you got 5 minutes, you got a lot of time, but check anyway so that you don't waste time. In this particular case, for example, calcium chloride, no precipitate there, sodium nitrate, nothing. So all I have to do is put NR as the product. So this one is nice and fast. NR, no reaction. I hit return, and it should give it to me. I don't know why it didn't give it to me. There's no reaction rate NR as the product. I did that. Yeah, okay, that I'll check out later. In any case, that's what you have to do. And good luck with this. Sorry about the NR not working. I don't know what's going on. If there's no reaction rate NR as the product, that's what I just did. Oh, I didn't hit check. Oh, silly me. Says correct. There is no reaction. Oh, you got to hit check, not just hit return in the blue box. Okay, that's it. Good luck with this. I think you'll see it's fine. The practice on here is actually easier than on the last one. You don't have to worry about those fancy things with the spaces. That's coming up again, though, in part 3 and part 4. Okay, we'll see you in class. Good luck. Thanks.